Hello viewers, welcome to MAGESH chemistry classes. In this presentation we will discuss about Carbene's chemistry. This is the syllabus for Trb Polytechnic and as its proposes examination also. First of all, what are carbenes? Carbenes are the type carbon hydrogen single bond with the lone pair electron or the lone pair electron with bivalent chlorine atoms and the carbon with lone pair electrons, alkyl groups, or the lone pair electrons, one alkoxy group and one alkyl group. These are the examples of carbene. From this, we can understand that these radicals are bivalent in nature. The two monovalent atoms are connected to the carbon atom with a sigma bond, and the lone pair electron is present. Okay. So this is the basic of your carbenes. Let us move into the properties of carbenes. Regarding properties, the carbon connected to the two monovalent groups with lone pair electrons. So around the carbon atoms only 6 electrons present. So it is sextet and it is electron deficient. So as it is electron deficient, it acts as a electrophiles in reactions. So mainly it is electrophile. In some cases it is acting as a radical. We will see later. And it is more reactive, highly reactive species. Why it is highly reactive? The electronic configuration, it has only 6 electrons in the outer cell. In order to occur octet system, it needs 2 electrons. So it is more reactive in chemical reactions. Divalent in nature. So total 6 electrons. The 2 electrons in the bonded and the 2 electrons are present in the non-bonding orbital and the 2 electrons present in the non-bonding orbital. Based on the electronic structure, it has 2 types. One is singlet, another one is triplet carbene. Okay. Next we see about the types of carbenes. The types of carbene based on the electronic structure. 2 types, one is singlet and another one is triplet. See the singlet carbene, it is connected to the monovalent hydrogen atom and the 2 unpaired electrons are distributed in the non-bonding orbital, and this is one unhybridized orbital. In this case, we see the 2 sigma bonds, total 4 electrons, and the 2 electrons are in the non-bonding orbital. This is your non-bonding orbital, not involved in the bond formation. And it is the hybridized orbital, sp2 hybridized orbital, and it is vacant. So carbon is sp2 hybridized. sp2 hybridized, what happens? It is trigonal planar in shape. Okay. So the expected bond angle is 120 degree, but the bond angle is 100 to 110 degree. This is because the lone pair and bond pair repulsion according to VSP theory. Lone pair and bond pair repulsion. And the two electrons are paired. So it is diamagnetic according to ESR system. Okay. The two electrons in the non-bonding orbital, and so the electronic repulsion is high. So energy of the system also high. So it reduces the stability. So less stable. So more reactive in nature. So the stability of the singlet and triplet is based on the electronic repulsion back bonding reason. We will discuss it. And it acts as a electrophile in the reaction. So in case of triplet, why it is called a singlet? Because the spin value is plus of and minus of, so total spin is 0. Spin multiplicity, that is 2s plus 1 is equal to 2 into 0 plus 1. So the value is 1, and so it is called a singlet. In case of triplet, the carbon is sp hybridized. So the two hydrogen atom, two sp orbitals. So it is in the linear format. So write like this. So linear. And the two sp orbitals are there. Structure. The two electrons are in the different orbital. The carbon is sp hybridized. sp hybridized is the linear in shape, and some cases it is bent. Next one, the expected bond angle is 180 degree, but here it is 136 degree to 150 degree. Two electrons are in same spin. So the S value is 1. 2s plus 1, this will 3, and so it is triplet. It is paramagnetic in nature. So the repulsion is minimized, and so somewhat it is stabler than that of the singlet carbene. So in general, triplet carbene is more stable than singlet. But the stability will depend upon various factors. The energy difference is around 8 kilocalories per mole. It is around 33 to 42 kilojoule mole inverse 1. Okay. Singlet carbene, the electrons are in opposite spin. They are in the paired in single orbital. Here the two electrons are in the same spin in the different orbital. sp2 hybridized and sp hybridized and trigonal planar, and it is linear and bent shape. And it is paired. The electron is not paired. Diamagnetic, paramagnetic, and somewhat it is little energy than that of the singlet carbenes. It acts as a electrophile, and in general, triplet acts as a radicals. So these are about your types of carbene. Next, we will go to the generation of carbenes. How the carbenes are generated in the systems. Carbenes are generated from, so one is from trihalogen compounds, chloroform. When chloroforms are treated with alkali like sodium hydroxide and or the potassium hydroxide, so it is base, it is acidic hydrogen. So the acidic hydrogen removed as H plus, so the carbon plus. This radical is formed, and then one of the chlorine is left out. You get the product CCl2 electron. The byproducts are water and KCl. Okay. This is an example of alpha elimination. The both hydrogen and chlorine is removed from the same carbon atom and it is alpha carbon atom. If the carbene formed is singlet, why it is singlet and why it is triplet we will discuss later. So here it is a singlet. Singlet is stabilized by the back bonding and triplet there is no stabilization. That's all the difference. We will discuss with the examples. So carbenes are obtained by alpha elimination of chloroform by treating with potassium hydroxide or sodium hydroxide. Then from diazo compounds. The diazo compounds are involving in the photolysis or thermal decomposition. We get so familiar examples by photolysis or the thermal decomposition we get this CH2. Here the hydrogen atoms are present, not involved in the back bonding with the non-bonding orbital. The carbene obtained from this diazo compound is said to be triplet. And from carbon tetrachloride treated with alkyl lithium. So methyl lithium, etc. Here the methyl group remove one, it is plus and it is minus. Methyl group remove one chlorine atom, you get the CCl3 minus, and chlorine is left out, you get the carbene singlet. And from heating like formula R2, single bond C, double bond C, double bond O. So this is double bond and heating. Heating by thermal or photolysis, you get the product R2C, heating and carbon monoxide. Okay. So these are the important methods of preparation of carbene. Carbene singlet, carbene triplets are only the 8 kilocalories per mole difference in nature, and these are distinguished by the paired electron or the unpaired electron with the same spin or different spin. So when it is treated in the low temperature or low pressure or inert gas atmosphere, the single carbene is converted into triplet carbene. Okay. Next we will discuss carbene in the reaction systems. Reactions of singlet carbene. The first one is insertion to the sigma bond. So a nice example, it is with the methane or like your ethyl compound, another compound. It is treated with carbene. Of the type, what happens, it inserted into this sigma bond. Okay. The product is that. Here the bond is inserted. So in this place it is inserted. See this one, the carbon the group is inserted. Okay. So this is called the insertion of sigma. The next one, addition to the bibond system. The singlet and your bi-system is like this. It is added to the bi-system. So the product is like this. So it is also cyclopropanation reaction. where the carbene is added to the insert to the sigma bond and also the bisystem. This is important reaction. And the third one, intramolecular reaction. In some cases, it involves in the intramolecular system. So it is similar to your 1,2 shift, etc. See this example, the type of carbene. Now there is a 1,2 shift. So this is 1 and this is 2. 1,2 shift takes place. The electron here. So such type of reaction is called intramolecular reaction. So this will be double bond. Here one hydrogen is shifted CH3. So in this type also takes place intramolecular reaction. Some cases dimerization. See this dimerization format is linked with the SO system plus double bond with the load paired electron. Here the carbene reacts. What is the product you get? R2C load paired electron N plus triple bond N and here on Cr2. Okay. H and decomposition to give R2C bond Cr2. So dimerization of the carbene takes place. And in the case of inorganic chemistry, halide formation also possible in this case. So totally the reactions are, the important reactions are, one is insertion to the sigma bond, addition to the bisystem is very important. And intramolecular reaction and dimerization also takes place in some cases. Okay. After this, we have discussed carbenes, properties of carbenes and the type of carbenes, which one is more stable and which one is diamagnetic in nature and paramagnetic in nature, how the carbenes are generated and how the carbenes are involved in the chemical reactions, etc. Now we will discuss about the stability of the carbenes and in some cases how the carbenes are affect the stereochemistry of the reactions in the examination point of view. See on questions. The question number 1. Suppose the different carbenes are given. CF2, CBr2, CCl2 and CI2. What is highest stable or decreasing order of stability of the singlet carbene? Question is decreasing order of stability of carbenes. What is the answer? The concept we applied here is back bonding. So in case of the fluorine, the electron is present in the non-bonding orbital. One is the sp2 hybrid orbital. Okay. The fluorine gives back bonding to this sp2 hybrid orbital, and so it gives the stability to the carbene system. Similarly, your bromine and iodine, etc. The electrons around the bromine involves in the back bonding system. And also your other halogens like your iodine, etc. Here the question is the decreasing order of stability of the carbene, which one is more stable, is important one. First concept is back bonding system, and your second one is which one gives more back bonding in nature. The order is the 2p is higher than that of 3p level, and 4p, finally 5p. Okay. So the back bonding maximum in the fluorine system. Clear? So your answer will be the CF2 gives more bonding system, back bonding system in the carbene. So CF2 is more singlet character than that of the your CCl2, than that of CBr2, than that of CI2. So in this way, you have to discuss your answer. Okay. So back bonding system increases stability, and the back bonding system order is 2p, 3p, 4p, etc. Clear? So this is your answer. The second is which is most stable. So this is the type of the carbene, and the X is the electron releasing group. The singlet carbene, triplet carbene are the both of them. So see the structure. The group is electron releasing group, and the non-bonding are placed there, and the 2 electrons are there. So previous question we discussed that the group which is electron releasing nature, electron releasing group, which releases the energy and makes the back bonding with the sp2 orbitals and increases stability in case of singlet carbene. In case of triplet carbene, there is a one electron in the pairing system and there is no back bonding, and it is the back bonding is less available. So singlet carbene is stabilized by the electron releasing group. Answer, we can say that the carbene with hydrogen atoms in the monovalent group and the carbene with the electron releasing group in the monovalent system. This is act as a triplet carbene, and it is as it is a stabilized system, and it acts as a singlet carbene in the stabilized system. Okay. So which is more stable? The X group is given the electron releasing group. If it is electron releasing group, the singlet carbene is stabilized. This is because the vacant sp2 orbitals by back bonding. So back bonding concept is very important to explain the stability of the bond. Clear? Example, the reactions are given. The question is the intermediate is. So what is the intermediate formed here? As we are studying about the carbene system, we can say easily it is the carbene is our answer. So what is the reaction? So it is a diazo system. So in the diazo condition, in presence of HNE, what happens? So it forms the biradicals. Yeah. So this biradical reacts with the bibond system. The addition of bibond system will make your cyclopropane system. We have studied in the product is when the cyclopropane system is formed, your methyl group is. So this is your product. So in this method, what is the intermediate developed? The carbene. Our answer is. This is a question from CSIR, June 11. See the fourth example. Here the cis compounds are given. It is treated separately with the singlet carbene and triplet carbene. What's the product we get? The A and B. A is cis and B is cis. A is trans and B is trans. A is cis, B is cis and trans. A trans and B cis and trans. In this example, we can study the stereochemistry of the singlet and triplet carbene. So in case of singlet carbene, what is the reaction type? So in case of cis, so this is your cis system with bi-electron. Here the two electrons are present. So bi bond is obtained by the overlapping of B orbital. So the two electrons are present in the opposite spin. When it is treated with the two electrons in the singlet system, it directly attached to this bibond system, you get the product like this. Cyclopropane system is attached here. Okay, so it is a cis product. You can say the cis singlet carbene is stereo specific in nature. Stereo specific. That is, when cis is the reactant, cis is the product. So specifically it gives the product. When trans is the reactant, we get the trans product. So these are about the stereochemistry of the singlet carbene. By nature, the bond formation is like this. Here the bond by electron and the two electrons are there. In case of triplet, what is the condition? The bi bond is there. The triplet carbene, both are in the same spin. Clear? So what happens? So one of the electrons from this bi bond and one of the electron from the carbene involves in the reaction. So we get like this. So here one bond is formed with the here one electron is there and also one electron is there. So we get the radical system. Okay. So to make the bond of the same spin, what happens? This CH2 or this bibond system will rotate so that the bond will be formed. So you get the product like this. These rotated to give this product, and also you get the product like this. Okay, so you get the product cis and trans. Here one electron species is one electron is the radical. When triplet carbene is involved in the reaction, it is stereoselective. The product is cis and trans. So we can conclude that when singlet carbene is used involved in the reaction, only one product is formed. Triplet carbenes are there, you get their two products. It is stereo specific, that is cis reactant gives cis product, trans reactant gives trans product. And it is stereo selective. The two products are formed, one is cis and trans. And the intermediate is here the singlet carbene act as a electrophile. Clear? And it is acting as a radicals in the reaction system. So these are about the stereochemistry of the singlet carbene and the triplet carbene. Okay viewers, these are about the carbene chemistry. Thank you for watching.